the unit circle. This is going to be another incredibly important part of trig. Think of this as your spouse. So you're going to love it, but it's also going to frustrate the heck out of you in certain situations. It's going to help you out as often as it can, but at the same time, it's going to expect that you know some things too. Today we're only going to focus on the angles of the unit circle. We will focus on the values of it later on, or I should say the special angles of the unit circle. Okay, so before we get into filling out the unit circle angles, I want you to first look at the 30, 60, 90 triangle and the 45, 45, 90 triangle. Fill in the blank or generic sides to these triangles. So I want you to try to remember how to do that on your own. I will give you a starting point here. This is X. So I want you to pause the video, fill in the 30, 60, 90, and the 45, 45, 90. Unpause when you're ready to check. Alright, so if we focus on the 30, 60, 90 triangle, I already gave you the hint that across from the 30 is X. Now, if you remember, then across from the 90 is going to be 2X. And across from the 60 is going to be X root 3. On the 45, 45, 90 triangle, across from both 45s are X. Since the angles are the same, the sides have to be the same. And then across from the 90 is going to be X root 2, where the hypotenuse is going to be X root 2. And so now you're asking yourself, and also it's written on your packet, this isn't geometry, so why do I care about these triangles anymore? Great question, except hopefully you can answer for yourself, and that is that trig focuses on triangles, and so these angles here are going to be what we call our special angles on the unit circle, or they're going to lead us to our special angles on the unit circle. So if we look at these angles, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, take a minute, convert them to radians. Pause the video, unpause when you're ready to check. So I did not show the work, but 30 degrees, to convert that to radians, remember we multiply by pi over 180. So 30 degrees is equivalent to pi 6. 45 times pi over 180 is pi 4th. 60 times pi over 180 is pi 3rds. And 90 times pi over 180 is pi halves, or pi over 2. These are going to be our special angles that we're going to focus on in radians on the unit circle. So now, what is the unit circle? Before we start filling in angles, well, the unit circle is a circle of radius 1 centered at the origin. The equation for that would look like this: x squared plus y squared equals 1. Hopefully you recall the equation of a circle from earlier this year, but if you don't, this would be our equation. Origin is the center, so that's why it's just x squared and y squared. Radius is 1, so 1 squared is 1. Okay, so now we're going to start to fill in the angles on the unit circle. So we know it's a circle of radius 1. That's not going to affect the angles, though. So notice that we're calling them our special angles, because again, any point along this edge of this circle is going to relate or correlate to some angle, but not all of those are going to be special angles. So where do we start? Well, when we're talking about angles, we're talking about angles in standard position. So remember, the initial side is the positive side of the x-axis. So what is the angle right there? If that's where I am on the unit circle, that's going to be an angle of 0 degrees. Okay, well, what's the next one? So as I continue to go up, these are going to be the special angles that we just talked about, the 30, 60, 90, 45, 45, 90 triangles. So out of those triangles, we have 30, 45, 60, and then 90. So the next angle here is going to be 30 degrees, and so that 30 degrees would be this angle. Here we will have 45 degrees, so this would be 45, where this is the terminal side of the 45 degree angle. So I hope you can guess the next one will be 60 degrees, and then here we have 90 degrees. So those are all of the special angles in quadrant 1. Now using those angles, I want you to try to fill in the rest of the angles in degrees on the unit circle. So I want you to pause the video, try to do that. Try not to cheat by looking above on your packet, and fill in the angles in degrees. Okay, so hopefully in the second quadrant, this should be 120 degrees, this should be 135 degrees, this should be 150 degrees. Here, halfway around, we know we have 180 degrees, and I apologize, my picture's a little bit deceiving. This terminal side here, that's the 210 degrees, so I'll turn it around. It's 210. Next we're going to have 225, then 240, 270 is 3/4 of the way. Then we have 300, 315, 330, and 360. You will need to memorize all of those. Part of what you're going to have coming up soon is a unit circle quiz, not tomorrow, don't worry, where you are going to have to fill in all of the angles in degrees, all of the angles in radians, and then all of the coordinates that go along with those locations. Again, we'll get to that stuff later. Right now we're just focusing on the angles in both degrees and radians. Okay, so that's what you should have filled in. Now, in terms of reference angles, so that's your big hint. What do you notice about all of the angles around the unit circle? So take a second, look at all those angles if you haven't realized this already, and then write down something that you notice about them with regards to reference angles. So pause the video and do that. Alright, so hopefully you noticed that all of these special angles that we looked at and that we labeled on the unit circle have a reference angle of either 30 degrees, 45 degrees, or 60 degrees. If you're not sure what I'm talking about, let's look back here. So let's look at this 210 degree angle that I drew. What is the reference angle? The reference angle is right here. That's 30 degrees. 150 degrees also has a reference angle of 30 degrees. 330 degrees has a reference angle of 30 degrees. We can do the same for the 45. So obviously 45 degrees has a reference angle of 45 degrees. But so does 135 degrees. (225 degrees) and 315 degrees also have reference angles of 45 degrees. And then we could do the same with the 60s. So the reason why I'm pointing this out, or one of the main reasons, is one, to show you that reference angles are useful, and two, to show you that when I say you have to regurgitate all of these angles on a quiz, you really just need to know 0, 30, 45, 60, and 90. And understand that everything else is going to have the same reference angles. So if you can do a little bit of arithmetic by adding and subtracting from 180 or 360, you can find all of the angles. Okay, so now we're going to look at the radians. We already looked, the angles are the same. The 30, the 45, the 60, the 90. We looked at converting those into radians, so we know that is pi 6, pi 4ths, pi 3rds, pi halves. But now I'm going to show you within the process an easy way to see the radians. Then we'll fill out the entire circle. So notice that the circle on your packet, and the circle I'm looking at right here, does not show all of the special angles. It just shows the quadrant angles. So 0, pi halves, pi, and 3 pi halves, or 90, 180, and 270. And then all of the angles with a reference angle of 45 degrees. So this is 45, or pi 4ths. This is going to be 135, and so on. Alright, so if you look at this circle, how many sections are there in this circle? How many slices? Think of this as a pizza. Pause the video, answer that. Okay, so hopefully you recognize there's 8 sections. Alright, so now in radians, what is the distance of one lap around the circle? What is the measure of one rotation around a circle in radians? So recall that that is 2 pi. So then what is the length of each section going to be? If I have 2 pi and I'm dividing it into 8 sections, I'm going to have each section be a length of pi over 4. So if I recognize that, I can count by pi fourths. I know I'm starting at 0, and then this will be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Now, these are not all the final answers because we're going to reduce. But this is one way to understand these angles. So if I start at 0, I count by 1s, or I count by pi fourths, I should say, going up by 1. So 0, 1 pi fourth, 2 pi fourths, which is actually pi halves, 3 pi fourths, 4 pi fourths, which is pi, 5 pi fourths, 6 pi fourths is 3 pi halves, 7 pi fourths, and 8 pi fourths, which is 2 pi. So that is 1 time around the circle in radians, marking off all of the angles with a reference angle of pi fourths or line on an axis. Next, I want you to draw in the lines for all of the angles with a reference angle of 30 degrees or 60 degrees. So pause the video and do that. Okay, so your circle should look something like this now, where on mine the red dots are the pi fourth or 45 degree angles that we are not drawing in. So now how many sections did we cut the circle into? Well, now you can see hopefully that there are 12 sections. We still know that it's 2 pi for the length around a circle. And so if we divide 2 pi by 12, how much is each section? It's going to be pi over 6. So 2 pi over 12 equals pi over 6. So we can do the same thing we did before, and we can count. So 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Again, we can go through and reduce these to get our final angles. So now I want you to put this together and fill out the entire unit circle in radians with reduced angles. So pause the video and do that. Okay, so your unit circle should look something like this. This angle is both 0 and 2 pi. And then we have pi 6, pi fourths, pi thirds, pi halves, 2 pi thirds, 3 pi fourths, 5 pi 6, pi. Going around. 7 pi 6, 5 pi fourths, 4 pi thirds, 3 pi halves, 5 pi thirds, 7 pi fourths, 11 pi sixths. So again, we are going to memorize those. I know, that's exciting. So now I want you to think about what are strategies you can use to memorize and understand these special angles on the unit circle in degrees. And same thing with the radians. What are strategies you can use? So write down a few and then we'll discuss. Pause the video and then we'll discuss again. Sorry, I said that twice. Okay, so the strategies are pretty similar for both. For degrees, the whole circle is 360 degrees. So if we slice it into equal sections and divide, we can find those angles. Know that every angle has a reference angle of 30, 45, or 60 degrees. And then same with the radius.